In this video, we'll use the series sum function and Linest in the polynomial regression and the expansion of this expression b0 plus b1 ln x. We begin with the values of b0 and b1. So data validation, list of items, -2 to +2. We can start with 1. Same thing with this, with b1. So data validation, list of items, -2 to +2. We can also start with 1. And now the function itself. So array formula b0 plus, that's plus b1 times ln of the x values. And we'll chart this. Insert scatter chart. Use row 1 as header, column A as label. For the series, we show the trend line. The type, we use the logarithmic. For the label, use the equation. For the legend, position at the bottom. So here's our equation and our trend line. Next, we continue with the expansion. In the expansion, we have here b0 plus b1 times the summation of a times x to the power x minus 1 raised to the power n. And the value of n starts from 1 up to infinity. So we can start with 1. 17 is good enough. And the value of a will be equal to minus our array formula minus 1 raised to the power of the quantity n minus 1 and minus 1. That's for the numerator. Now the denominator. The denominator is n. Sure. So here we have the expansion coefficient. Now we continue with the Maclaurin series sum. So R formula, series sum of the x values. The x is not x values, x minus 1. X minus 1 raised to the power n, where n starts from 1, incremented by 1. And the coefficient, it will be coefficient a will be this range. And we show the equation. Edit chart, customize, series, trend line, logarithmic. For the label, use the equation. And here's the equation. They're far out, so we'll correct this. So we factor in b1. So this is multiplied by b1. So times b1. Enter. Next, we add b0. So plus b0. Plus b0. Now they're on the same trend line. And you can toggle this if this is -1 or if this is 0. So this one, we'll calculate this logarithmic regression coefficients using Linest. To do that, we complete the Linest matrix. This will be our Linest matrix, the 1 column and the ln x column. So this is our formula of the x values, raised to the power 0. That's for the one column. The lnx column array formula ln of the x values. Now we can use linest. So to do that, this is linest. This time it's data y and data x. It's 1, 1. So 1, that's 1 plus 1 ln x. So this is 1 plus 1 ln x. We continue with the expansion. This is equal to linest data y and data x. Well, expansion is only an approximation, but it's still good enough as an approximation. So, so here we have 1, that's 1, plus 0.99 ln x. If we change this to negative 1, so we have 1 minus ln x. On this side, you have 0.99 minus 0.998 ln x. We can change this to 2. This will be 1 minus 2 ln x. So 1 minus 2 ln x. Here we have the expansion, which is 0.999 minus 1.997 ln x. Change this to 2. So we have 2, this is 2 minus 2 ln x. This is 1.999 minus 1.997 ln x. Or we can reverse this. This will be negative 2. And this will be positive 2. Now we have minus 2 plus 2 ln x. Here we have minus 1.99 plus 1.997 ln x. This completes the use of the Linest logarithmic regression and the Taylor-Maclaurin series sum to generate a trend line and dataset of the expression b0 plus b1 ln x.